In the previous lecture, we discussed the definition of differentiable function. That is, we discussed the differentiability, and then we discussed the necessary and sufficient condition for the differentiable function. And we saw some example of differential function. Now, in the today's lecture, we have to discuss the differentials. So today's our topic is differentials. First we discuss the differential for the one variable function, and then we go for the two variable function. Suppose we have any function, one variable function. Which function we are taking? Suppose we have a one variable function y is equal to f of x. Then what we can define? Then we define what we define a differential. Which differential? Dx as an independent variable. Then the differential dy is defined as, the differential dy is defined as dy is equal to what we can write, f dash of x dx. Now we draw a diagram which showing the relationship between what? Increment. Yesterday we defined increment in y is delta y, and today we define what? Increment, and today we define differential dy. What it means? What is the exact difference between the increment in y and differential of y? So how we define this? How we interpret this? Suppose we have any curve like this, and we are taking derivative, that is f dash of a. It is what? It is the slope of the tangent. That means you have to draw the tangent at a point, specific point. Suppose this is our a, is it? Then what we can say, that this is a tangent line. You can write the equation for this. Y is equal to f of a plus f dash of a into x minus a. This is the tangent. It has a slope f dash of a, and this is our curve y is equal to f of x. This is our curve. Suppose we are taking the change, that is the change in a is a to a plus delta x. Now we define, this is our what? This is our dx is equal to delta x. Is it? Dx is equal to delta x, both the distance. But here we are getting the two distances, that is the distance or change in height of the tangent and change in height of the curve. This is one distance, and this is the our what? Increment in y, and this is our distance differential. This is our dy. So what is this? What we can say, that the differential. What differential? Differential dy represent the change in height. A change in height of the tangent and what? the increment delta y represent, what it represent? Change in height of the what? Curve y is equal to f of x. When it is? When x changes to x plus delta x. Okay, or you can write when a changes to a plus delta x also, no problem. Okay, what it means, this increment in y is just a change in height of the curve, and this differential is change in height of the tangent when a changes to a plus delta x, that is in a change delta x we can say. Now similarly we have to write it for all this for what? Differentiable, that is all this differential for two variable function. Now what we consider for this, what we have to consider, let z is equal to f of xy is a differential function of two variables. Then dx and dy are the two, are the what, which it is, dependent or independent, are the differentials. And what? And these are independent differential. Then what we have to do? Then what we can say? Then the differential. Which differential? The differential dz is defined as. What dz is defined as? Dz is equal to what? What we can write? Fx at xy dx plus fy at xy dy. What it means? Instead of this fx we can write dou by z by dou by x dx plus dou by z by dou by y dy. Okay, this differential dz is also called what? Total differential. It is also called as the total differential. Sometimes we can use df in place of dz also. Okay, that is df can be written in place of dz. Instead of dz we can write a df, or in some books there is a notation df is also there. If we put what? Dx is equal to delta x is equal to x minus a, and dy is equal to delta y, it is equal to what? Y minus b. Then what we can write? Then what we can say? This dz is equal to what? Dou by z, or we can write dou by z by dou by x, or we can write this fx at ab. Here dx we are written here x minus a plus fy at ab. In dy can be written as y minus B. And if you try to remember this, we have what we have, the approximation or the linear approximation is linear approximation. What is it? Linear approximation is f of xy is approximately equal to f of AB plus fx AB x minus a plus fy AB y minus b. And what it means, this can be written, it is in the form of this linear approximation can be written in the form of differential, that is, this is nothing but our FAB plus dz. So this is the linear approximation in the notation of differential, So getting this, what we did here, similar definition, here we take z is equal to f of xy, then we define independent variable dx and dy, these are the two differential which are independent, and then we define a differential dz, it is equal to fx xy dx plus fy xy dy, and this is nothing but we can write it is in the symbol of z also, that is dz also can be written in the notation of df also, and then we put just this and we are getting the linear approximation in the formula of dz. Okay, now we have to take the geometrical interpretation of this. So if you see the figure in the book, it is similar to the one variable function, just we have to convert this, it is into the three-dimensional function. So what we can observe from this diagram, I am not going to draw the diagram, you can see it is in the book, but just you have to take result like this. What is the delta y? What is delta y? It is the increment in y, and this increment in y is showing that what it represents, change in height of the curve. Similarly here dz, this shows that here is a curve in three dimension, there will be a surface. Z is equal to f of xy is a surface, therefore we can say that dz represent the height of the surface, and dx and dy, here only dy, there is dx and dy, this dx and dy represent the height of the tangent plane. Here is a tangent, so in the three dimension there will be a tangent plane. Okay, if I draw the diagram like this, just I am drawing, it is rough diagram, not a fully diagram, I draw this here. Just we say that if here is a my one plane, here is a one plane, tangent plane, and there is a my we can say here is a our surface, there is a my surface, this, and here is, this is the plane, and we can say that this is my this is the chain. Okay, so what we can say that there is a diagram like this. This is the our surface, and this distance, we can say that this distance is our delta z. What it means? This represent the change in what? Change in height of the surface, and this is my, what we can say that dz, that is differential dz, and this represent this change in height of the tangent plane when x changes to x plus delta x and y changes to y plus delta y. Is it? So So what we discuss here, delta z, that is increment in z, increment in z, what it is delta z, and it is the change in height of surface z is equal to f of xy, and differential dz is change in what? Height of tangent plane. When it is if x changes to x plus delta x and y changes to y plus delta y. Is it? So this is the relationship between the delta z and dz. Okay. So we solve one example. What is first example? If z is equal to f of xy is equal to x square plus 3xy minus y square, find the differential dz. So what is our first target? Find the differential dz. And then second question, if change in x is from 2 to 2.05 and y changes from 3 to 2.96, compare the value of delta z and dz. That is, we have to find the values of delta z and dz. For this we have given change in x 2 to 2.05 and y is from 3 to 3.96. Okay. So we solve the example. So what is given? First we solve first. Given z is equal to f of xy is equal to x square plus 3x y minus y square. We have to find what? We have to find first derivative, that is dA by z by dA by x. How we find dA by z by dA by x? It is 2x minus plus 3y. What is dA by z by dA by y? It should be what? It should be what? 3x minus 2y. The differential dz is what? What is the definition? dz is equal to dA by z by dA by x dx plus dA by z by dA by y dy. Okay, so what we can write here? What is dA by z by dA by x? It is 2x plus 3y dx plus what we can write dA by z by dA by y? It is 3x minus 2y dy, and this is our required dz. Why it is? Because in the first problem or in the first part we have not given values of x and y. So this is our required dz for first part. Now what we have to take? We have to solve the second, that is the B problem or problem number. This is first A and this is our B. Now what we have to show? This is B, suppose. So what we can say that we have x changes from 2 to 2.05. So what we have? We have x is equal to what? 2 and x plus delta x is equal to 2.05, and therefore what we can say? Delta x is equal to what? It is equal to, that is 2.05 minus 2, it should be what? 0.05. Similarly we have given y changes from 3 to 2.96. So y is equal to what? 3, and it changes from y plus delta y, it is equal to what we have given? 2.96. So what should be delta y? Delta y, it is equal to what? 2.96 minus 3, it should be minus 0.04, minus 0.04. Now we have to put all this value in equation number 1. Okay, so put put all these values in equation 1. So what we are getting dz? dz is equal to, what is 2? 2 into x is 2 plus 3 into y is what? 3. Okay, into what? Our dx. Dx is nothing but our dx is equal to delta x. Dx is equal to delta x. Therefore, what we can write? It should be our dx. It is nothing but our dy. Okay, so it should be what? 0.05 plus what we can write? It is 3 into what? 2 minus 2 into 3 into our dy is nothing but our minus 0.04. Now you can do the calculation, that is 2 2s are 4, 4, 9 3s are 9, 4 plus it is 13, 0.05 plus what? 2 3 2s are 6, 6, 6 minus 6 is 0, minus, okay, so this should be 0, and it is equal to what? It is equal to what? 13 5s are 65, and how much digit you have to given? It is 0.65. So our dz is 0.65. Now what we have to find in the next? We have to find what we have to find? Delta z, that is the increment in z. Now what we can find? Now we find what? Increment in z, that is delta z. So delta z, it is equal to, delta z is equal to what? What is the definition? F of, what we can write? F of x plus delta x, y plus delta y, minus what we can write? F of xy, f of xy. What is our x plus delta x? This is nothing but our what? X plus delta x is what? 2.05. Here is what? 2.96 minus f of, here x is 2 and y is 3. Is it? Then it is equal to, now just put the values in the function, given function. What is given function? So write down all these values. This is nothing but our what? 2.05 square plus 3 into 2.05 into 2.96 minus what? 2.96 bracket square minus what? Again you have to put here xy is equal to 2 3. So similarly you have to write 2 square plus 3 into 2 into 3 minus what? 3 square, and if you do simplification, this we will get 0.6449. So this is our required dz. This is our required dz. If this is equation number 2, say this is equation number 3. So what we can observe from 2 and 3, we can observe that dz is approximately equal to delta z. They are approximately equal to delta z. It is 0.65, and it is also near about 5. It is again near about 0.65. So but what we can say, which one is easy? Which one is easy for calculation? I think this is easy, but dz is easier to compute. That is, this can we find very easily, but this is difficult to find. Okay, so in the similar way we will solve one more problem. Now we solve second example. So what is the example? The base radius and the height of a right circular cone measured as 10 centimeter and 25 centimeter respectively. Okay, with the possible error in measurement of as much as 0.1 centimeter in each. Use the differential to estimate the maximum error in the calculated volume of the cone. So what we have to do, we have given one cone, circular cone is given, and we have a given its base radius and height of the cone, and this is given, we have 10 and 25 centimeter respectively. Now what in the that is there is a possible error in measurement is of 0.1 centimeter, and now we have to estimate the maximum error in the calculated volume of the cone. So how we find this? Again we have to use the formula of a differential. Okay, so we write a solution. So let what we have to write, V be the volume of the circular cone whose height is h and base radius is r. That is V be the volume. Then what is the formula? Then the volume of cone is, what is volume of cone? V is equal to pi by 3 r square h. Then what we see here, therefore V is a function of two variables. Which two variables? R and H. It is the two variable function, that is variables are R and H. Then the differential dV is equal to what? dV is equal to, write down the now formula that we can write deva V by deva R dr plus deva V by deva H dH. Okay. Now for this what we have to find? We need to find the deva V by deva R. So what is, we have a function, say this is equation 1, this is equation 2. From equation 1 we can find deva V by deva R. So it is equal to what? Deva V by deva R, that is pi by 3 is constant, and what R square derivative is 2R into what? Into H. So this should be 3 by 2 pi R H, and deva V by deva H, it is equal to, differentiate this with respect to what? H. So it should be pi by 3 R square, H derivative is 1. Now we can put from equation 2, what we can write? Just put the values. dV is equal to deva V by deva R. What is deva V by deva R? Put the value. This is 2 pi by 3 R H into what? dr. Plus what we can write? Deva V by deva H, pi by 3 R square into dH. Say this is equation number 3. Also what we have given that? We have given that what? We have given the radius, base radius is what? 10 centimeter, and what? Height is H is equal to what? 25 centimeter. Also we have given what? Maximum error, maximum possible error, maximum possible error is what? 0.1. That means what we can write? That is mod of dr is less than or equal to what? 0.1, and mod of dH is also less than or equal to 0.h. That means it is the maximum error. For we have to find maximum, so we take dr is equal to 0.1 and dh is equal to also 0.1. Now put all this value in equation 3. So from equation 3, what we can write? dv is equal to 2 pi by 3 into r. R is what? R is our R, we can write it is 10 into h is our 25. Is it? Then into what? Into what we have to write? dr is 0.1 plus write down pi by 3 and r is 10 square and h is 0.1. Just do the simplification here. What we are getting? 25 tens are 250, 2s are 500, 500 pi by 3, is it? Into what? 0.1 plus what we can write? Pi by 3, 10 square. That means how much it is? It is 10 square is 100 pi by 3 into 0.1. And therefore what we can write here? Here we can write here 0.1 which multiplied this, so it should be 50 by 3 pi plus here again you do simplification 10 pi by 3 and 50 plus 10 is 60 pi by 3 and it should be 20 pi. Therefore what we can say? Thus the required error is 20 pi. If you put the value of pi is 3.14 and if you did multiplication, this should be our 63 centimeter cube. It is 63 centimeter cube. Okay. So in the similar way we can find the error. Okay. So we will discuss more problem. It is in the practical session. Thank you very much.